Hello, and welcome to today's lesson on Standard 2.3a in Algebra 2, and then also the Study Island topic quadratic equations. I'm so glad that you're joining us today. Today we're going to be looking at how to solve quadratic equations, and there's 4 different ways that we can solve quadratic equations. The questions on the EOI might say solve this using this method, but if you prefer using your graphic calculator, do it that way. If you prefer to use the quadratic formula, then do it that way. It doesn't matter. There's very few questions where you have to use the way that they say. If you're successful another way, then it's okay to use that way also. And then just remember that you should be taking notes as we're going through the lesson. If I go too fast, just pause and get caught back up. And then you can even pause before a question. You work it out, see if you get the answer that I do, and that way you can learn from your mistakes if you made any, or learn that you're doing great. So I'm glad that you're here, and let's go ahead and look at some notes. When we solve quadratic equations, there's going to be 4 main ways that we are looking at how to solve them. So the first way is going to be graphing. In graphing, you're looking at where it touches the x-axis. So if you have something above the x-axis or below, it's going to have no answers, so no real roots. If you have something that touches in just one spot, so just the vertex touches that x-axis, it's going to have one answer, one solution, and you can also have it where the U-shaped graph touches both, and that's going to have 2 solutions. You could use the quadratic formula, you could use factoring, or you could use completing the square. And we're going to look at an example of how to solve using each of these. But the important thing is to remember is each one you could solve it. It is your choice, you could pick. But each one is going to get you the same answer. So just most of the time you can pick the one that you are the most comfortable with and stick with it. And remember though that when they ask you for the solutions of a quadratic equation, any of these 4 vocabulary words here, roots, solutions, zero, x-intercepts, could be used. But if they ask you for the roots, if they ask you for the solutions, if they ask you for the zeros, they ask you for the x-intercepts, they're asking for all of the same thing. It's just 4 different vocabulary words for the same question. This first one we're looking at how to solve by graphing, and it says how many solutions are there to the quadratic equation represented above? Well, I have this u, and to find my solutions, I want to find where it crosses the x-axis. Well, this u is never going to touch the x-axis, so it's never going to have any real solutions, so my answer is B. And here's another one. This u actually touches the x-axis in 2 places, so that means it's going to have 2 solutions, which is letter A. This question here is an example of one of the few times you can't just pick regardless of what the directions say. Here you have to know how to fill in the number for completing the square. And the way that you do that when there's no coefficient in front of the x squared is you take your middle term here, so that's going to be negative 10, my b term, and I'm going to divide that by 2, so negative 10 divided by 2 is negative 5. And then I'm going to square negative 5. Negative 5 times negative 5 is positive 25. So doing those 2 steps of dividing by 2 and then squaring is going to give me the number that I need to add to both sides in order to complete the square. So my answer here is A. Okay, number 2 here, it gives us 4 problems, and it wants to know which one of these 4 problems has the solutions 10, negative 2. So one thing you could do is you could just put these into a graphing calculator and see which ones cross and have the x-intercepts of 10 and negative 2. But if you want to do it algebraically, since I know these my solutions are whole numbers, I'm going to use, I think factoring is the best way to do it algebraically. So letter A here is going to factor it into x minus 10 and x plus 2. So I'm going to have to set each of those equal to 0. So I have x minus 10 equal to 0 and x plus 2 equal to 0. And when I solve those, I get x equals 10 and x equals negative 2, which is what I'm looking for. And so my answer here is going to be A. However, it's also always a good idea to double check that the other ones don't work out too and that you don't have a mistake somewhere. So I want to show you how B would work also. So B, I actually can't factor that. There's not a pair of numbers that multiply to negative 20 but add to negative 8. So since I can't factor it, it's not going to have a whole number solution. So this problem here asks you to solve by completing the square, but on the EOI, if you wanted to set this equal to 0 and put it in your graphing calculator, you could do that. Or if you wanted to try to factor it, you could do that, or use the quadratic equation, you could do that. So, but with completing the square, you're going to find that magical number that we talked about at the beginning and see what it is that you're going to add to both sides. The nice part about this problem is that it already has it x squared x equals the number. You don't have to set it equal to 0 this time. So what I did is I went ahead and rewrote it, but I left a space for that where I can add that magical number to both sides. So I'm going to go over here and find that magical number. Negative 8 divided by 2 is negative 4. And then negative 4 squared is 16. So I'm just going to add 16 to both sides. And the reason that I do that is because this is going to factor into x minus 4 quantity squared. And then 33 plus 16 is 49. And what's awesome about that is I can just take the square root of both sides. And this square root and this square cancel, and I'm just left with x minus 4 on the left side. And then the square root of 49 is plus 7 or minus 7. So that means I'm going to have x minus 4 equal to positive 7 to solve for, and x minus 4 equal to negative 7 to solve for. And so when I add 4 to both sides, I end up with x equals 11. And when I add 4 to both sides on this side, I'm left with x equals negative 3. And so those are my two answers for what x can equal. So my final answer is C. This next equation asks us to solve using the quadratic formula. To use the quadratic formula, though, it has to be in standard form. So it has to be equal to 0. So I'm going to have to go ahead and solve this for 0. So I'm going to go ahead and distribute that x, and it's going to give me negative 2x squared minus 13x equals negative 4, and that needs to be set equal to 0, so I'm going to add 4 to both sides. And it's going to give me negative 2x squared minus 13x plus 4, and then the 4's cancel on the right side, so it is equal to 0. Which is what I need to use the quadratic equation. So here, the coefficient in front of my x squared is going to be my a, so my a here is negative 2. The coefficient in front of my x term is negative 13, so my b is negative 13. And then my constant, the number at the end, by itself is 4, so my c is 4. So now I'm just going to take these three numbers and substitute it in correctly into this equation. And so when I do that, I'm going to have the opposite of b, or negative b, is 13. The opposite of negative 13 is positive 13. Plus or minus the square root of b squared. So I'm going to put that negative 13 in parentheses, squared, minus 4 times my a number, negative 2, times my c number, 4. So here, And that's going to be all over 2 times a, which is negative 2. So I'm going to have 13 plus or minus negative 13 squared is 169. And then negative 4 times negative 2 times 4 is a positive 32. So it's going to be plus 32. And then on the bottom, 2 times negative 2 is negative 4. The next thing I have to do is to go ahead and add these numbers underneath the square root. So that 13 plus or minus the square root is going to stay the same, but 169 plus 32 is a 201. And it's all over negative 4. And now there's nothing left I can do to simplify this. There's no perfect squares to simplify out of the 201. And there's nothing I can simplify in all 3 of these terms. So that's going to be my answer. And then my negative is just going to move up here to be with the 13. So that makes A my final answer. Number 40 here, there's no middle term. So that means my B number would be 0. And the nice part about this is because there's just the x squared term, there's not an x squared term and an x term, is I can just go ahead and add this 25 to both sides. Cancels on the left, and I'm left with x squared equals 25. And then you're going to take the square root of both sides. So and that cancels out that squared and leaves me just the plain old x that I'm hoping for. And then that leaves me with plus or minus 5 as my answer. So positive 5 squared is 25, and positive negative squared is also positive 25. So that's why I have 2 answers. And so C is the one that says that I can have negative 5 and positive 5. So that's my final answer. So this problem here tells us that it's easier to graph when our quadratic function is in vertex form versus when it is in standard form. So it wants you to use completing the square to take this from standard form to vertex form. I'm going to show you how to do that, but if you forget, you could take each of these answers and FOIL out the parentheses and then distribute and combine like terms. So you could take each of these and work backwards to see which one gives you this, if that's easier for you. So in order to do this, I'm going to want to go ahead and find that mystery number that I'm going to have to add in to make this a perfect square trinomial. The first thing I'm going to do is I'm going to look at just the coefficient on the x squared in the x term and see if there's anything that I can factor out of just those 2. Here I can factor out a 2, so that's going to leave me with x squared minus 2x. And this is where I'm going to see what can I add on to that to make it a perfect square trinomial. But then I'm going to have to do the opposite of that. I'm going to have to add the opposite of that at the end also in order to keep this equation balanced. So here, remember to find that magical number, I'm going to take that b term and divide it by 2, so that gives me negative 1, and then square that, which gives me positive 1. So that means I'm going to add 1 and then subtract its opposite, or add its opposite. And so here though, what I have, it's not just going to be a 1, because this 1 is also being multiplied by the 2, that I'm actually adding a positive 2 to this equation. So to keep it balanced, I'm going to have to add the opposite of that, which is minus 2. And now I'm ready to continue to convert this to vertex form. This perfect square trinomial here is going to factor into x minus 1, that quantity squared. And then at the end here, 11 plus negative 2 is positive 9. And that's going to be my final answer with the little squared there. which is letter B. Thank you for joining us today, and I hope you learned something new.